In this ClimateGenn episode, I'm speaking with Dr. Jennifer Francis, a senior scientist at the Woodwell Climate Research Center in the US. 2023 has already seen record-breaking temperatures in the atmosphere, land, and oceans, with horrific impacts to human life, communities, and ecology. Here we focus on three factors in the climate system that drive these extremes and are still set to break more records, creating a great deal more destruction this year. We focus on the forming El Niño climate phenomenon, as well as ocean heat waves impacting the Atlantic and the North Pacific. Finally, we also discuss the role of the thinning sea ice that is accelerating change in the Arctic region. These changes drive up heat in the Arctic faster, impacting ecosystems and altering the jet stream. These latter impacts being the focus of Dr. Francis's research for over a decade. You can support this channel via Patreon or by becoming a YouTube member, where episodes appear early, and for water and food level members, there is access to a growing number of longer, unpublished and previously unseen content. Thank you. Jennifer, it's excellent to see you again.
Great to see you, Nick.
Thank you. I want to start by really referring to a tweet of yours recently where you highlighted ocean heat waves and El Niño and polar sea ice lows as three components of the climate system that are giving cause for concern. Can you start by giving us an overview? We'll start with maybe sea ice and what's going on in the polar regions at the moment.
Yeah, there's a lot going on in the climate system, a lot of change. The impending El Niño is getting most of the headlines because we know El Niños. They're a natural phenomenon, and we're just coming off of a 3-year stretch with La Niña, which is the opposite. So a La Niña is when there's colder than normal water stretching from, say, the coast of Peru across the equatorial part of the Pacific Ocean, and El Niño is the opposite. So it's when there's a lot of extra warm water piled up along the coast of Peru that extends across the equatorial part of the Pacific. And both of those have impacts on weather systems, mostly in the Pacific and Eastern Pacific, but it can also affect things like the hurricane season in the Atlantic and perhaps even the weather patterns in Australia and the Southern Ocean. So El Niño and La Niña have been a very important forecasting tool that meteorologists and climate scientists have used to try to get some handle on what the weather's going to do months in advance. But now there's a lot more going on. And yes, we have this El Niño developing. It looks like it could be a strong one. We tend to see global average temperatures spike when an El Niño occurs. So this is very concerning because even during these last 3 years of La Niña, we've seen near record-breaking global average temperatures. So I've been saying for a long time, including on Twitter, that when we get the next El Niño, we better watch out because we're probably going to see a big spike in the global average temperature. But contributing also to that are a number of oceanic heat waves. You could call El Niño an oceanic heat wave. That it's one that we've seen. It occurs in the same place all the time. But we're also seeing a huge patch of much above normal ocean temperatures across the North Pacific, and the Atlantic Ocean right now is running a fever. Almost the entire Atlantic Ocean is above normal ocean temperatures. So this is also very concerning because even though El Niño years, we tend to see fewer hurricanes in the Atlantic, in the North Atlantic, that's probably not going to happen this year because the Atlantic Ocean is so darn warm, and that is the fuel for hurricanes in the Atlantic. So this is a big offsetting factor to the impacts of El Niño on the Atlantic hurricane season. But then we've also got the Arctic. So the last few years, the sea ice has been continuing to run at very low extents. We haven't broken a new low record since 2012, but every year since then, there's been much less sea ice than it used to be only, say, 30, 40 years ago. But even more concerning is the sea ice is getting much thinner. So even though the extent has been relatively steady the last few years, we've seen thickness of that ice decrease. And that is very concerning because thinner ice is much more easily moved by the winds. It's much easier to melt it. And so I think there's a good chance we're going to see some near record low sea ice extents this year as we have all this heat that's built up in the North Atlantic and the North Pacific and now El Nino. So there's a lot of heat going into the system. And we're also seeing the Arctic run very warm. Boy, it's just been getting warmer and warmer. And the Arctic is warming about 4 times faster than the globe as a whole. And this is something that really has driven my research over the last more than a decade now, is trying to understand how this rapidly warming Arctic relative to the rest of the globe is going to affect weather patterns around the Northern Hemisphere. And we're seeing this Arctic just continue to warm faster than elsewhere. And I think that has played a role in some of these extreme weather events that have been unfolding across Europe, across North America, in the East, pretty much everywhere around the Northern Hemisphere. I think we're seeing at least some role being played by this rapidly warming Arctic. And of course, it's a difficult thing to look at an extreme event and say, yep, this is caused by that, or, there's a factor of some portion that's being caused by something. But I think the understanding has been getting deeper in how some of these things are affecting weather patterns. But as I said, there's so many factors that are evolving at the same time that are all connected to all these heat trapping gases we've been dumping into the atmosphere. It's really hard to untangle which is having the biggest role in any given event that we might experience.
Okay. Wow. I mean, all of that together raises a few different questions. With the sea ice, you were saying that we haven't had a record low since 2012, but you're losing a lot of volume or thickness. Does that mean that we're becoming more and more vulnerable to a sort of almost like a rapid drop off if you're losing the thickness? So one year you might just get a big boom and lose a great deal, and that'll be the next new low, going forward kind of.
Yes. And in fact, that's what happened in 2012 was we had a very persistent wind pattern up in the Arctic that basically blew all the ice from one area to another and also brought a lot of heat in from lower latitudes from the south. And so both of those things contributed to the rapid loss of sea ice that summer. So, yeah, we are now actually more vulnerable than we were then. So if that pattern or a similar pattern were to set up, it's definitely much more likely now that we'll see, a big drop in the sea ice.
And with that event, I suppose it becomes a bit more self-reinforcing in terms of heating the Arctic Ocean.
Yeah, and in fact, that albedo feedback that you're mentioning is the main driver of the Arctic warming so much faster than elsewhere. So as we lose that sea ice and snow cover on land, it means that the surface underneath that ice or snow is now exposed and it's darker. And so it absorbs a lot more of the sun's heat, which then goes into the ocean instead or to the soil, and it melts more ice, which retreats more, allows more sun to be absorbed. So this is the feedback part of that story. And if we did lose a lot of sea ice in any given year, or even in any given region, which is what we tend to see, is that certain regions lose a lot of ice. It has a big impact, especially on the local area and the local marine ecosystem. So all this warm water tends to pool in that area, which has a big effect on the algae, which, is the base of the food chain, and that affects all the other animals that feed on that and feed on each other. So there have been huge shifts in the marine ecosystem in the Arctic because of the loss of sea ice, and that would be just made all that much worse if we were to have a big ice loss some summer.
Does that apply as well to the ocean heat waves you're talking about in different parts of the, say, North Atlantic or North Pacific, in terms of ecosystem impacts or even human communities?
Yes, anytime the ocean temperatures are outside of the normal experience of the animals that live in that area, you're going to see impacts. Shifting species, die-offs. Maybe 5 years ago, we saw a lot of seals and fish dying along the west coast of North America when there was a strong oceanic heat wave that was right up on the coast. So yes, we definitely see big impacts on the marine ecosystem anytime the ocean temperatures change.
Okay, and just coming back to the Arctic sea ice, and you mentioned that this has been the focus of your study for just over a decade, and I think I spoke to you almost a decade ago for the first time about this.
Mm-hmm.
And if you cast your mind back to then, how has your research understanding changed and the rate of change? These two sort of things, are you expecting to see what you see now, or have things changed in your view?
Yeah, so as we and other researchers have dug into this issue of how the rapidly warming Arctic is going to affect the larger scale circulation and weather patterns, it's only gotten more interesting, I would say, because the more we learn, the more we realize that there's a lot of pieces we don't understand. So these oceanic heat waves is one aspect of this, and how the rapidly warming Arctic affects the usual way that we expect an El Nino to affect weather patterns. These two things interact with each other. The oceanic heat wave in the North Pacific is a really much more closely connected to what goes on in the Arctic because it's much closer in distance, but also the jet stream that runs around the Northern Hemisphere interacts more closely with that heat pool in the North Pacific, which then can affect the jet stream. And if the Arctic is also warm, that can make that pattern that evolves even more intense. So we're also looking much more closely at the higher levels of the atmosphere. So everybody's now heard of the polar vortex. Well, that is a wind pattern that sits over the North Pole, but much higher in the atmosphere, up in the stratosphere, that is also looking like it's responding to changes in the climate system, and perhaps particularly to certain areas where the sea ice has disappeared. So we've seen that when the polar vortex, which generally is this circular, strong wind around the North Pole, tends to stay up there and not really bother anybody. It's only there in the wintertime, unlike the jet stream. But occasionally it gets disrupted. So instead of being circular and strong, it'll get stretched into a sort of a bean shape, or it'll get split into separate whirls. And we know when that happens, we see a lot of very unusual weather conditions in the wintertime around the Northern Hemisphere. So understanding how those disruptions happen and whether there's a role being played by the loss of sea ice has been an intense focus of research. So I guess to sort of sum it up into one neat package, I'd say the whole story has gotten much more complicated, much more interesting. It's an exciting time to be a scientist studying this stuff. And there's a lot at stake. There's a lot of risk to billions of people. And so it's a really important topic to try to understand so that we can help decision makers prepare for the kinds of extreme weather events that are likely to happen in the future as we continue to warm the planet.
Taking that point of what you can see now, this point that it is more complicated and you've got these systems that sort of interact with each other, what do you foresee this year? More chaos, or how do you see it?
That's a tough question. And of course, it's the $64 million question, because everybody wants to know, are we going to have a really hot, dry summer and wildfires, or are we going to see flooding? Are we going to see a lot of hurricanes? What's going to happen? And there's a lot of people trying to make those what we call seasonal forecasts. But I'd say that our ability to make those seasonal forecasts is still evolving. And the research that we're doing is certainly helping. But we're in a new uncharted territory. We have not had a strong El Nino in conjunction with ocean heat wave in the North Pacific, in conjunction with an Atlantic Ocean that is, the temperatures are almost off the charts. So, this combination of factors is really nothing that we've seen before. So it's a real challenge to make any kind of a prediction. I think you said it very well. That is, expect chaos, expect unusual events, expect certainly extreme events. We're going to see heat waves. We're going to see floods. We're going to see some strong hurricanes, rapidly intensifying hurricanes. Those are all symptoms of climate change that are very clear. But pinpointing exactly where and when they're going to happen is still a big challenge.
Okay. And obviously, we expect to be reducing emissions, which is causing all of these problems. And unfortunately, emissions seem to continue to rise. We don't know if they're going to continue rising a lot. But given that we are in this new regime, this uncharted territory, we're not doing what we need to do. And it doesn't look like the politicians are really moving in that direction. If you were facing President Biden now, for example, and he asked you for a risk report as straight talking, what would you say?
I'd say you got to put your foot on the pedal and push it all the way to the metal. We've got to do everything we can possibly do. The United States is making a lot of progress, I would say. It's not fast enough. It is, definitely much later than we wished it had happened. But, today's the next best time to really get going on this stuff. But it's not just about reducing emissions. We definitely have to do that. We have to stop cutting down forests because they're our best natural solution for removing carbon from the atmosphere. We've got to stop destroying mangrove areas because they're another natural way that the climate system removes carbon from the atmosphere. So we've got to not only stop emitting carbon, or at least slow it down as much as we possibly can for so many reasons, not just for the climate system, but for health reasons, for national security reasons. There's so many reasons why we need to kick our addiction to fossil fuels. But there's also the natural solutions that already exist in the climate system need to be reinforced. So really stepping up our efforts to protect the large forests around the globe. The Amazon comes to mind. Thank goodness there's a new leader in Brazil who understands how important this problem is. But, the other side is we know that we're going to see an increase in extreme weather events, continuing rising sea levels, continuing ocean acidification. Some of those things we cannot stop. And so we have to prepare people. We have to think about, those communities that are going to be affected and whether it makes sense to rebuild a home on the shore that has been destroyed 3 times in the last 20 years. Does it make sense to rebuild along a river that has flooded or that has dried up almost? There are these areas where they're undergoing these extreme events over and over and over again. Does it make sense to spend tax dollars on rebuilding in places that are just going to get destroyed again? So those are very hard conversations to have with people because, that's their home.
This new regime you're talking about, this new climate adaptation is one thing, but maladaptation could be equally damaging. So do you see we have to find a healthy way to retreat into the safer zone, or probably away from extreme coastlines and so on?
I do. And like I said, it's a hard one, though, because you're talking to people about leaving their homes. Maybe they have multiple generations that have lived in a certain place. And so, it's a tough one. But on the other hand, I think the insurance industry is kind of helping with this because they are refusing to insure certain places. And that's going to drive a lot of movement, too, because property values are going to go down if you can't get insurance for a home or a building or whatever it is in a certain place. So there are a lot of sort of moving parts to that story. But I think it doesn't make sense to spend tax dollars to rebuild, to provide insurance to people who can't get it otherwise, to build in these places that are obviously vulnerable and they're just going to get destroyed again. But as I said, that's a hard one for people to swallow.
Just one to finish on. When we spoke last time, I think we mentioned these sort of interventions with geoengineering, and the last COP, I noticed there was a lot more discussion than I've heard before, and it seemed to be getting a lot of attention. And I've got a feeling that the next COP there's going to be more discussion around, putting particulates in the stratosphere and also large-scale greenhouse gas removal. You were very anti this before. What's your position now? Is it the same?
I'm very anti doing it, but I'm very pro researching the impacts of doing it. So, using our very sophisticated climate system models to illustrate what could happen if, say, some rogue actor were to put a bunch of stratospheric reflectors up there to reflect more of the sun's energy back out to space so it doesn't come down to the earth. We have natural stories that we can show that when we have major volcanic eruptions, the Earth does tend to cool temporarily, but there's a whole suite of issues surrounding doing this kind of an intervention. Who decides when to do it, where to do it, who's going to pay for it, who decides when, say, one region experiences a severe drought and they blame whoever did this intervention? How is that going to get resolved? We just don't know what a lot of the actual impacts are going to be. And think of it as a Band-Aid on festering cancer wound. We need to get at the disease. And I think by doing some of these interventions, it gives people a sense that something is being done so they don't have to worry about cutting back on carbon and moving over to renewables, and we don't have to worry about cutting down forests anymore. That's not true, because we would still be putting carbon into the atmosphere. And if we ever were to stop that intervention, we'd see a very large and abrupt increase in global temperature, and all kinds of bad things would happen as a result. And so I think there's just so many social, scientific, economic, national security issues surrounding doing anything like this that it is a very bad idea.
Okay. That's very clear. Okay, well, look, thank you very much. That's been really insightful. And I was going to ask you if how you generally felt, positive or negative towards the outlook, but I think it is really, it is quite self-evident. It is what it is.
There's a lot of reason for hope, though. I mean, I think the young generation, young people especially, are seeing that this is the world they're going to inherit. And I think there's a lot of really bright, energetic, determined young people and old people now too, who are really just focused on trying to do better. So I see a lot of positive things happening, especially on more local and state levels. And I think that's going to drive a lot of good things as we go forward. And, every 100th of a degree that we can keep the world from warming is going to be helpful. So, we can't turn this ship around, but we can certainly slow it down.
Okay. Great place to end. So thank you very much.
You're welcome. Great to see you again.